In our earlier video regarding congruent triangles, we saw the SAS condition, the SAS postulate, meaning that if two sides of a triangle is equal to the two sides of another and the included angle, the angle between the sides are equal to one another, then the triangles are said to be, that implies that both the triangles are congruent. This is what we arrived at in our earlier video, right? So we called this as the SAS postulate, meaning that if two sides and one included angle are equal in two triangles, then both the triangles are said to be congruent. So just that these two, this side is equal to this side and the included angle are equal, then the two triangles are said to be congruent. Now in this video we are going to explore if there are any more conditions which ensure the congruence of two triangles. Now look at the idea where three angles are congruent, AAA, meaning three angles of any triangle are equal, of any two triangles are equal. If the, let's assume a case where I draw one triangle here and let me call the angles 1, 2 and 3, and if I have another triangle where the angle corresponding to angle 1 is also angle 1 and this is angle 2 and this is angle 3, the measures of the angles are same, can I prove that, or can I say that these two triangles are congruent? Let me take an example for this. Maybe I have a right angle triangle, right angled at here 90, and another right angle triangle, right, 90 here, 90 degrees, and I assume that this is 45 and this is 45. These two angles are 45 degree each. Still, I cannot ensure that the sides are equal. I cannot ensure that the sides are the same. It may be small, it may be big, but only thing I can ensure is that the second triangle would be a scaled up or a scaled down triangle of the first one. It would either be, scaled up or scaled down. It would either be small or big. The angles would be the same, but you cannot place one on the other and say that they coincide with the other. So they are not congruent. They may be scaled up or scaled down. That is, suppose this is x centimeters, this would be some n times x, maybe 3x or 4x or 5x, so it would be some n times x, and second side also would be the same n times. If this is y, this would be n times y, and same for the third side also. So my conclusion is that if I say that three angles of two triangles, the three corresponding angles of two triangles are equal, then I cannot say that the triangles are congruent to one another. So this postulate does not hold good. But given that this does not hold good, let me have a case where all the three angles, I should have written AAA, all the three corresponding angles are equal and one more side is equal. Let's see that case. So what I mean is, the side is not scaled up or scaled down, it's exactly the same. So given that the three angles, the three corresponding angles are equal, meaning this is 1, this is also 1. If this is 2, this is also 2. If this is 3, this is also 3. Given that the measure of the three angles are equal, then, and I am also assured that one of the sides, maybe this side, the corresponding side is equal to the other corresponding side. What do I conclude from this? I conclude that the second triangle is neither a scaled up nor a scaled down figure of the first triangle, but it is very much the same as the first triangle. So, in addition to the three angles being equal, if I am told that any one of the sides is equal, I can assure that the triangles are congruent triangles, right? I hope you understood, but there is a hitch here. Even if two angles are given, and one angle was not mentioned, if you go by the property of sum of the angles of a triangle, sum of the angles of a triangle says that it was always equal to 180 degrees. So when you are given two angles, when two angles of the triangle are fixed, it automatically means that the third angle is 180 minus the sum of those two angles, isn't it? So the third angle has to be the same. So from this condition follows the second postulate, which is ASA, angle side angle, or AAS, angle side. Both are one and the same. Any of the two angles are corresponding angles. If it's given to be equal and a side, corresponding side is given to be equal, then the triangles are congruent. It need not be the included side, because given two angles, the third angle is automatically the same, right? So you don't have to read these postulates differently as AAS or ASA. You can just say that if any two angles correspond to one another and one side is the same, then the triangles have to be congruent. And from this postulate, can we start thinking about any other postulate where, suppose if the angles are not mentioned at all, nothing about the angles are mentioned, but it is given that all sides are equal. Can you just think about this? All sides, the corresponding sides are equal. Can we think of such a scenario where two triangles are given and the corresponding sides are equal? Are these two triangles congruent? Let's look at this in our next video and find whether if three sides are given, S are given to be equal, are the triangles congruent? Thank you.